So hey everyone, in this video we are going to solve all the problems that are related to LeetCode arrays which are medium level. Okay, so in one of those videos we had solved all the problems that are easy. So in this video we are going to solve all the problems that are medium, okay, and the most popular ones, okay, which are most likely to be asked in your interviews. Okay, so this is one of the most popular problem within LeetCode interviews when it comes to medium level. So that is 3 sum. Okay, so we had previously solved a problem called 2 sum, and this is the next level to that is 3 sum. Okay, so here in this problem we just need to will be given a array over here. We just need to return an array of arrays containing triplets. Okay, so we see that we are having a nums array, and we just need to return which are all the arrays that contains triplets. So what do I mean by triplet? Where when I add all the numbers from the array, which will give us the sum of 0. Okay, so we see that this is, if I add -1 and 2, the sum is 0. Okay, and again same goes for this as well. So we just need to find those triplets, and there cannot contain any duplicate triplets. Okay, so that's also a condition here. So let us understand how can we actually solve this. So these are the set of numbers that are given to solve the 3 sum problem. So the brute force way of solving this, let me just go through it very quickly. So we can use triple for loops. Yeah, triple for loops is very terrible in terms of performance, because the time complexity would become O of n cube. Okay, so that would become like, if we have 6 numbers here, it would become 6 to the power of 3 comparisons that we need to make. Okay, it's somewhere around 200 to 300 comparisons, which is terribly slow. Okay, so we just need to avoid this. So what ideally we would do is, like, if you want to like solve using the triple for loop, we would set I, j and k as pointers, and we just need to keep on just checking by adding I, j and k, and if they equal to 0, so if they do, then we just have a results array, and we just push that one. So -1, 0 and 1. So actually in this case they equal to 0, so we add that to the results array. So we just keep on doing that, then we increment k, again keep doing the check. The problem here is we are recalculating the same thing again and again. Okay, so that's very bad in terms of performance, because we are even checking that were previously calculated. Okay, so that's why we just want to avoid this, and we just keep on incrementing k. So once k is out of range, then we increment j and set k next to j, the next value of it. Again keep doing the same comparisons. So once j and k are also out of range, then we increment I. Okay, set I, j and k, and then again keep doing this again and again. Okay, so this is as I told, very terrible. So we just want to come up with a better solution. Okay, so we just want to reduce the time complexity, which currently is O of n cube. Okay, which we need to avoid, and we just need to come up with a better solutions. How can we actually make this better? So in order to make this solve in an efficient way, what we can just do is we can just sort this particular array. So if we sort this, it would become first is -4. So starting with the very last element, then comes -1, again -1, then 0, then we have 1, and then 2. Okay, so this is the sorted array. Once we sort it, so our array becomes like this, and this the sort operation, as you know, it takes a time complexity of n log n. All right, and here once we do this, we just need to, the step 2 is to convert this to a 2 sum. Okay, currently we have 3 sum, we are just given a simple array. If you remember, within the 2 sum problem we had two values, one is the target and the array itself. Okay, so here again we need to consider one element as the target and rest of the elements as the array, which is actually given in 2 sum problem. Okay, so for that, to solve this, once we have sorted the array, if you remember, in 2 sum also the array was actually sorted. So we just need to keep track of, again, 3 pointers over here. So in 2 sum we had 2 pointers, because here we need a extra pointer for the target value. Okay, so let us consider the target value of, let's say, I. Okay, and the next value, that is the start value of the actual array, so that would be right next to I. So that is the next value of I, that is j, which is pointing at -1 currently, and then we want to set k to the last element, like this. Okay, so now we just need to keep on this becomes like a 2 sum, so where I is the target, j is pointing at the first element within the array, and then k is at pointing at the last element. Okay, as I told you, I is the target, right? So we just need to negate this. Okay, so we just need to if it is minus, we just need to make it plus. If it is a positive value, again we need to make it a negative value. Okay, so we are just flipping the integer sign over here. So here the target becomes 4, and this becomes our potential array which we need to perform two sum on. Okay, so j is at pointing at -1 and then k is at -2. So now we just need to check by adding j and k. Okay, so if we add j and k, it becomes +1. So 1 is like greater than 4 or less than 4. It is less than 4, right? So that is why we increment j. So now again we add j and k. So again the value is 1. So 1 is less than 4. Again we increment j. Okay, so now as we just need to keep on doing this as long as it is equal to the value I. Okay, so currently it is 4. So j and k, so if we add them both, that is again still less than 4. So we increment j, and then we add this, the sum is again equal to 3. 3 is less than 4. Then we just again increment j. Now j is like out of range, so basically j and k are the same value. So we just need to reset. We need to increment I and go to the next iteration. Okay, so this time with this actual particular iteration of I, we do not find any potential triplet. So this iteration fails. So we just go to the next iteration. So now we need to increment I. So I comes here, and as I said, j is the immediate next to I, so that is over here, and k is set at the last element. So we need to reset things by incrementing I again. So now we just need to as I told, invert this particular I value, the integer one. So if it is minus, make it plus, and vice versa. So the target is now 1. Okay, so this becomes our potential array, okay, which we need to perform two sum on. So we just need to add j and k and check if that is greater than or less than the target value, and then if it is equal, then we add that to the results array. Okay, so now we add -1 and 2. -1 and 2 is equal to 1. Okay, so that is the target, which means that this is the actual triplet which can be formed. Okay, within the results array that we have over here. So we just add the triplet, and we need to make sure that we convert this back to the original sign over here. So we add -1, and this the value of j, that is again -1, and the value of k, that is 2. Okay, so this will be an array of arrays containing triplets. Okay, so then we just need to keep on adding. So once this is done, we now move to the next iteration. So now we either increment j or k, that's not a problem. So we increment j over here. Again we see we try to add j and k in if that is greater than 1 or less than 1, or if it is equal 1. So you see that 2 is greater than 1. So this time I decrement k. Okay, so since 2 is greater than 1, so I decrement k like this. Okay, so now again I check 0 plus 1 is equal to the target 1 over here. Okay, so again this forms a triplet. So I again add that to the results array. So now the target value is 1. We need to again invert it back to -1. So it becomes -1, 1, and then sorry, 0 and then 1. You see that this forms a triplet, -1, 0 and 1. Okay, so now we again increment j or decrement k. So now you see that they are overlapping. This condition fails where j is less than k. So now we go to the next iteration. So by incrementing I, so we just reset this. All right, so this becomes I now, and as I told, j is the next value, and then the k is to the last. Okay, I hope you get the idea. So we can just try to keep on doing this. And there is one catch here. They have told in the problem statement that this should not contain duplicate triplets. Okay, so you see that within this particular iteration, so if I just bring k over here, just for example, so you see that this is forming a again it's forming a triplet, but we already have that within our results array. Okay, so for this, what we can just do is we just need to check the previous value of I if it is the same value as the next value. Okay, so you see that previously I was -1, and during the next iteration it is still -1. So what we just do is we just want to skip this iteration. So we just want to increment I again as long as the previous value is not the same as the current value. Okay, so I place I over here, and then j here, and then k, and then keep doing that. And also we need to perform the same for j and k as well, in order to avoid an extra iteration. So if the next value of j is same as the previous one, then we just want to skip that because we have already checked it. Okay, there's no point in again checking it. So that will actually improve a bit of performance. So this is how you can solve this three-sum problem. So as I told you, let me just give you a small recap. So the first step is to sort the given array. Okay, and once the array is sorted, this takes a time complexity of O of n log n. So once we sort this, we just need to convert this to a two sum. Okay, considering the I element, the I pointer to be the target value, and rest of the elements to be the actual value or the two sum array. Okay, so from there we just keep on performing, and we just, as I told, we need to invert the value of I in order to make the comparison to like a two sum, and then we just keep on doing that. And if we, in order to avoid any kind of duplicates, we just need to check the previous value. If it is the same as the current value, then we skip that iteration. The same goes for I and j as well. Okay, so this is how you can solve the three sum problem, and this is the final array which we can return at the end of the problem. So what is the time complexity involved? So the time complexity over here is actually O of n square. Okay, because we are performing the two sum multiple times. Okay, so we are just performing for the first iteration, that is for the I, and then we just perform two sum, and then increment I, again perform the two sum for the rest of the elements. So that is why this time complexity is O of n square. So in this kind of problems, so the time complexity, if it is O of n square, then that's not a problem, because the problem itself is like that. We can, if we are helpless to bring the time complexity to O of n, and the space complexity is O of 1 or O of n, I'm not sure, because yeah, actually it is O of n, because the worst case is that we might have all the triplets within the given array. Okay, so we'll be having the whole array itself as triplets. So the worst case is O of n, and the best thing is we have reduced the time complexity, which we saw in the brute force way of O of n cube, to we have just reduced it to O of n square. Okay, so that's the big performance shift. So this is the problem on three sum. Let us see how can we code this inside LeetCode. So let us start by sorting the nums array. So we can say nums dot sort, where we have the two comparison elements a and b. These two, we just want to sort them in ascending order, right? So we just say a minus b, and once they are sorted, we just need to now initialize a results array. So we can say result and set that to an empty array. So this will contain all of our triplets. So once we find a particular triplet, we just want to push that to this results array. Okay, so once this is done, we can now run a for loop by initializing the three pointers. So let us start by setting the value of I, which will be the target when it comes to two sums. So let's set initially to 0, and then I is less than nums dot length minus 1, and then incrementing I. So this time it's not minus 1, it is minus 2. I'll tell you why. Because we will be having two more pointers, that is j and k. Okay, so we just don't want to go up to that extreme, because we need to have place for j and k as well. So that is why we just want to decrement another value from here. Okay, so that's why we are minus 2 over here. So now let us initialize the left and the right pointer. So basically you can say j or k also, but it would make more sense to name this left and right. Okay, so I'm going to set let left equals I plus 1, because as we saw, we just need to set the value of the j or the left to the next value of I. So that's why we set I plus 1, and we just need to do the same for the last element as well. We can just, that is basically the k which I give you an explanation. We can just call this right, and we can set that to the last element. So we can do nums dot length minus 1. Okay, and since arrays are 0 based, we have to minus 1. So now we can just put a while loop. Okay, so we can just run the two pointers over there. So the condition here is the left should always be less than right. Okay, so if that condition fails, then we want to go to the next iteration of I. Okay, where I will be the target, where left and the right will be the two pointers within the actual array or the potential array. Okay, so let us first calculate the sum of left, right, and then the value of I. Okay, so the reason is we don't have to invert the value of I, because when we calculate the sum of these, it will anyways be equal to 0. Okay, so I'll just show you that. So we calculate the addition of nums at the value of I, and the same for nums at left and right. Okay, so this is also you can do, or you can set the value of nums at I, or also we can put a check over here. Okay, so we can just say if the negative value of nums at I, if that is equal to the sum of nums at left and nums at right. So you can also do this. Okay, so I think this makes more sense and cleaner to read as well. And now we just need to check if the sum is equal to 0, which means that this is actually a triplet. So we just want to push that to the results array. So we just want to check if sum is equal to 0, then we just want to do result dot push. Okay, so basically the three values over here, and this should be an array of arrays, right, within this result. So we can just put that inside an array like this and then push it to that. Okay, we just want to increment left and decrement right. Okay, so let me just expand this. We just want to increment left and then decrement right. Sorry, this should come inside this. Okay, so now if this is not the case where the sum is not equal to 0, which means that we need to check if that is lesser than 0 or greater than 0. So based on that, we increment the value of left or decrement the value of right. Okay, so let us handle that within the else block. So else if sum is less than 0, then we just want to increment left just as we saw. And if that's not the case, we can just handle that within else. We just want to decrement right. All right, so I hope that makes sense. So if you remember, we didn't tackle one problem, that is the solution set must not contain duplicate triplets. Okay, so what we can just do for that is we can put a while loop again inside this and keep checking if the next value of I, okay, so the value of I over here, so the next value of that, if it actually is the same as the previous one, so we just want to skip that. So as long as it the same value appears, so we just want to keep skipping that. So we can just handle that within a while loop. Okay, so before we increment left or decrement right, so we want to run that loop here. So while we can just put a condition here, nums at left, and if that is equal to nums at left plus 1, so the next value of left, then we just want to increment left. The same goes for right. Okay, so we can just duplicate this and just change this to right, and then we, instead of incrementing right, we just want to decrement it. Okay, and also we just need to put another condition here. We are not checking if left is less than right, so we want to put that check over here again. Okay, so while left is less than right and this thing. Okay, so we can do the same for here as well, because in some cases the right value will be greater than left. So in that case, it doesn't make sense to do this. Okay, so and one more thing is even for the I value, so if the previous value of I is same as the current one, we just want to skip that. Okay, so we can just handle that here as well. So we can set if the value of I is greater than 0, and if nums at I is equal to the nums at I plus 1, then we just want to skip that iteration. So to skip that iteration, we can say continue. All right, so this is the case which we do. So we just want to skip this iteration. So if it is it doesn't go any further, so it will just increment the value of I within this for loop. Okay, so I hope that made sense. And yeah, so that is it. Finally, we just return the result. Okay, so I hope there's no errors here. So while talking and typing, as you know, I make mistakes. So let's run this and see if it passes. My bad, this should be -1 because we are checking the previous value and not the next value here as well. Okay, so we just don't increment right by 1, we just want to decrement. Okay, since we are decrementing right from the back. So now let's run and see. And also I had to separate this by comma. I'm too lazy, I just copy paste and this is what happens. Okay, so let's now run this. Yeah, there we go. So our solution is accepted, and let's see our performance. Okay, so that's looking good. So this is the solution for the problem 3 sum. So I hope you liked it. Let's now move on to the next problem. So this is a problem called container with most water. Okay, so you see that they have given a diagram over here, and we just need to calculate what is the maximum area that if we pour water, that would become the maximum value, so that would hold most amount of water. So basically we need to calculate the area which is the maximum. So you see the area, so that is 7 multiplied by the 7 columns that we have, so that is 49, just as we see over here. Okay, so that is the maximum water it can hold. So this is the problem statement. Let us understand how can we solve this. So to solve this problem, we are given an array of heights where we just need to calculate which one is the container which is holding the most water, where these are the heights, and the width is like between what to what we are actually checking. Okay, so what is the brute force way or the naive way of solving this is of course by using the nested for loops. Okay, so what we just do is we set a pointer I over here and j. Okay, for each of them we'll have a for loop, and we just need to keep on doing the comparisons. Okay, so we just need to have a formula over here. So we need to calculate the height. So which one is the minimum value? So between 1 and 8, so 1 is the minimum value, right? So that this will become the height. Okay, because greater than 1, it water will overflow, so we just want to consider the minimum value. So this is the height, sorry, this height is equal to 1, and the width is actually the difference between the two indexes. Okay, so the indices, so j is at the first index and I is at the 0th index, so we just calculate the difference between them. So the width would become 1 minus 0, so that is 1. So how do we calculate the area? So we multiply 1 into 1, so the value of that will become 1, and we need to keep track of a max variable, and initially it will be 0, and anytime the actual value that the area we get is greater than the max value, then we update that. Okay, if not, it will be the same value. Okay, so we just need to keep on doing this, and of course this is a nested for loop which will take a time complexity of n square. Okay, so currently we have 9 elements, so it has to make 9 to the power 2, that is 81 comparisons. Okay, so which is not ideal, and we just need to, of course, as I told, need to avoid any kind of nested for loops. So we just need to solve this in a better way. So how do we solve this? So here comes the two pointer approach to the rescue. So what we do is we set the initial pointer I to pointing at the first element, and the another pointer, let's say j, pointing at the last element within the heights array. Okay, so here we just need to keep doing the same thing just as we did in the brute force. So we calculate the height. So the height is the minimum value from I and j. So here the height is 1, and the what is the width? So the width is j minus I. So j is at the 9th index, right? So we need to subtract that with 0. So 9 minus 0 becomes 9. So we just need to multiply 9 by 1, and we just need to update the max value. So here also we'll be having a max variable. Initially it will be 0, and we just need to update this to the maximum value. So here it becomes 9, because 9 is greater than 0. If anything is greater than the max, we update that. If not, we let it be the same. Okay, so we have done the first iteration. So now we just need to increment the value of I or decrement the value of j. So how do we do that? How do we on what basis do we increment I or j? So we need to check which the value of I, which is 1, and the value of j, which is 7. So if the value of I is greater than the value of j, then we just decrement j. If not, if value of I is less than j, then we increment I. Okay, so in this case the value of I is less than j, so we increment I. If not, we decrement j. Okay, so now we again keep doing the same thing. So we check the minimum value, that is j, okay, which is 7. So the height becomes 7 this time. And what is the width? So the I is at the first index and j is at the 9th index. So 9 minus 1 is 8. Sorry, 8. J is at the 8th index. Okay, so I forgot that arrays are 0 based. So j is at the 8th index. So this max has to be 8 and not 9. Okay, so this becomes 8, and we just need to update this to again 7, because 8 minus 1 is 7. So multiplying 7 by 7 becomes 49. So the product is 49, and we just update the max value because 49 is greater than 8. So the max value is 49. Okay, and we just now increment or decrement j. So now we see that I is greater than j this time. Okay, so that is why we decrement j. All right, so now we keep doing the same thing. So the 8 and 3, which one is the least value? That is 3. Okay, so the height becomes 3, and the width is j minus I. So this time it is 7 minus 1, that is 6. So 6 into 3 is 18, and we check that to the max value. So 49 is greater than 18, so we don't update the value, we go to the next iteration and we keep doing the same thing. Okay, so this is how you can solve this, and the best part is we have reduced the time complexity from O of n square to just O of n. Okay, so this is the performance shift that we get by using the two pointer approach. And what is the space complexity? Are we creating any extra variables? We are just creating one, but this is irrespective of the length of the array. Okay, so that is why we can safely declare the space complexities O of 1. Okay, so this is the solution to this problem, container with most water. Let us see how can we solve this by code. So let us start by initializing the first pointer, that is I. Okay, or you can call this left. So I'm just going to call this left for better sense. So I'm going to initialize that to 0. So this is the left pointer, and I'm also going to initialize the right, which is going to be the last value within the heights array. So that is heights dot length. All right, so now we just want to also keep track of a max variable, so I'm just going to initialize that as well. All right, so now we can just run a while loop. Okay, so while left is less than right, so keeping the boundary set, and inside this while loop we just want to calculate the minimum value from the height that we have. Okay, so we just store that within a const min height and set that equal to math dot min, and we just need to pass in the value at left and value at right. So height at left and height at right. Please expand this. All right, so once we do that, we get the minimum height, and now we just need to calculate the width. So let's call this width, and this is going to be the difference between left and the right. Okay, so right minus left. Okay, so anyways, right is always greater than left, so we don't have to take the absolute value of that. So now we can finally calculate the area by, we can say, min height, multiply that by the width. Okay, and now we just update the max variable. Okay, calculate the maximum. Okay, we pass in the max and then the area. So if the maximum, if the particular value is greater than the existing value, then it will update that. If not, it will remain the same value. So now we also need to update the pointers, right? So either we want to increment left or decrement right. So we just want to check that. So if height at left is less than the value of right, then we just want to increment left, just as I explained. The same thing we just want to do for the right as well. So else decrement right. So if this condition doesn't meet, okay, so finally we return max. Okay, so I hope that's clear. Did I make any mistake? Nope. Let's now execute this and check if it passes or not. Yes, it does. And now let's submit. All right, so that's looking good. Okay, so this is the solution for the problem container with most water. So now let's move to the next problem. So this is a problem called as set matrix zeros. Okay, so we will be given a matrix. So a matrix is actually represented as an array of arrays like this. All right, so what the problem states is that if an element is found 0, we need to set the entire row and column to zeros. Okay, so they have given an example over here where this is a matrix which is actually represented in this way, where you see that this element is actually 0, right? So this has a row and this has a column, right? So we need to make all the values within the row and column as zeros, just as you see over here. And you see in this example we have two zeros over here, so this also has a row and column. We need to make all the columns and rows as zeros, just as you see over here. Okay, so let us understand how can we solve this. This is the given matrix. Okay, so this is basically in the form of array of arrays, so you can just consider it like this. So basically this is one array with comma separated for each value. Okay, so if you feel a little bit of difficulty in understanding, so this is basically an array of arrays. Okay, so you can just consider this to be the matrix. Okay, so let us understand how can we solve this in a brute force way, okay, or the naive way, which is not at all optimal. Okay, so basically what we do is we store the index of each row and each column where the zero is actually present. Okay, so you see that there is a zero present exactly in the middle. So what is the index of the row and column? That is 1 and 1, right? So that is at row index 1 and column index 1. So basically you see that this is the second element within this particular array, right? So that is the index, that is 1. Okay, and which column it is? So again, this is 0, this is 1, because arrays are 0 based. So what is the row? So which row it is? So basically this will be in the form of a set. Okay, so this is a set, and which actual row it is? So that is row number 1. So this will be array of values. So basically this is a set. Okay, so which will hold currently all the unique values. And then we have the column. Okay, so which particular column does 0 contain? So that is column number 1. Okay, after that we need to create another for loop, like for every row. Okay, so what are all the columns that are present? So if we consider this row, which is row number 1, so there are 3 columns, right? So column number 1, 2, sorry, 0, 1 and 2. Okay, and then we need to make all the values as 0. So we just make these values as 0. Okay, so once we do for the row, again we go to the column and do the same. So basically column is number 1. So basically this column over here where the 0 is present, so we just make the column value static, that is column number 1, and then we just go across every row. So we just go across every row and mark the values as 0. Okay, so this is the brute force way of solving this problem. So what is the problem over here? We are using nested for loops. Okay, that is 3 times. Okay, so the first time is to find the exact row and column number where the 0 is actually present. Okay, so for that we use a double for loop. So I'll also show you the code after this. In order to mark these zeros from the row wise and the column wise, we also need to create another for loop for that. So that is 2 nested for loops. So totally there are 3 nested for loops, and of course the time complexity would become O of n square. Okay, so that is into 3. Okay, so n square plus n square plus n square, which should still constitute to O of n square. All right, so this is the time complexity. And what is the space complexity? The worst case is that we'll have every single column or the row which will be a 0, right? So we'll be having this row set and column set filled with values, okay, based on the column size and the row size. So that is why the time space complexity would become O of n, since it is dependent on the number of values, okay, that we have within our matrix. So this is the brute force way, and let us now understand how do we solve this in a much efficient way without all of these nested for loops and the space complexity. So to solve this in the most efficient way, we need to follow a particular strategy, which will be of 4 steps. Okay, so the first step is to check if any 0 contains within the first column and the first row. Okay, so currently we do not have any zeros, so basically we need to check and store within a flag. Okay, so let's say first row has zeros or something. So first row has 0 and we set that to either true or false. Again we just do the same for the column as well. Okay, so we store these flags. So what we are doing here is we are marking the first row or column that we just need to make all the values 0. Okay, so if there is a 0 contained over here, we need to mark this value as true. So again we need to do the same for the other elements as well. So we go to the right, basically the next element, and check if this is a 0, so this is not a 0. So if this was a 0, then we make the left and the top elements as 0. Okay, so this is not a 0, so we don't do that. So once we completed all the columns, then we move on to the next row. Okay, so here there is 1, again we don't do that operation, and then finally go to the last elements. We don't have 0, so we just don't apply that particular thing. Okay, so this is the next step. So basically the second step. Okay, so the next step is to fill all the values with zeros. So currently we have marked this particular row as 0, right? So we just need to mark the entire row as 0. Okay, so just as the rule says, whenever we find a 0, okay, so we need to make all the rows and the columns as zeros, right? So again we apply the loop just as we did in the brute force. Wherever there we find the row value as 0, so we mark the entire row as zeros. Okay, so when we consider the row number 1, so for every column that the row has, we need to mark them as 0. Okay, so we marked this as 0. Okay, now we again go to the column. So we have this value as 0, right? So we go across every element within every row within this column and mark that one as 0. Okay, so the best part about this is we are not creating any additional data structure just as they mentioned in the problem. So we just need to use this in constant space. Okay, so we just don't want to create any additional data structure except for these flags, which are actually independent of the number of values we have within our matrix. Okay, so once we do this, so this was the third step, and the final step is, remember we had set the flags of this first row has 0 and column has 0. So previously it was so just for explaining, I had marked this to true. So basically this is false. Okay, same as here as well. So basically this is false, so we don't execute the fourth step. Okay, so whenever the value is true, basically we have a 0 with any one of the row or column. So basically based on that, this will be true or false. Let's say we had a 0 here previously. Okay, so let's say on this column, so we need to, like, mark this entire column as 0. So this is on the first row, right? So basically at the 0th index within this main array, so we just mark every element from there as 0. Okay, so again we just run a loop and then mark every element from there as 0. So let's say if we had a 0 over here. Okay, so let me just undo this. If we had a 0 here, now the column has the value of true. Okay, so we just set this to true, and then based on every row we just mark all the values within this particular column as 0. Okay, so this is the solution. So let us consider another example here in case you haven't understood the previous example. Okay, so if you understood, feel free to skip this particular part. So this is the example where we have a 3x4 matrix, okay, which is an array of arrays. So let us go across the 4 steps that I mentioned. So what is the first step? You need to check whether the first row and the first column contains any 0. Okay, so you see that right away the first row, it contains a particular 0, but the column doesn't contain any 0. Okay, so we just maintain a flag. Okay, at the end of the 3 steps and during the final step, then we add all those zeros. Okay, so we can just say first row has zeros, so just in a short form. So I'm just going to set this to true because we have a 0 over here. So first row has 0, so that is true, and first column has 0, that is false. Okay, so first step is done. So in the next step, we need to start from the first element, sorry, the first index from the row and the column, and we just need to check if that is a 0 or not. Okay, so if that is a 0, then we mark the particular row or the column as a 0. Okay, so once we mark that, later in the third step, we just populate all the zeros in that particular row as 0. So starting from the first index from the row and the column, so we immediately found that there is a 0 over here. Okay, so now we need to mark the row and the column as zeros. So we can just go to the left. Okay, so we found that there is a 2 over here, so we just replace this by a 0, and then also for the column. Okay, so we replace the 7 by a 0. So now we go to the next iteration, so that is the next column within that same row. Okay, once we have completed all the rows, then we go to the next column. So now we check this is not a 0. Okay, so this is not a 0, this is not a 0, this is not a 0, this is not a 0. In case we found a 0 over here, let's say for 6, so we mark this, the left element, that is the row, as 0, and then the column. Okay, so we are just marking. Later in the third step, we are going to populate all the rows and columns with that particular 0, okay, as zeros. So this is the second step which we have done. So we have marked these two as zeros. So in the third step, we just need to populate this entire row and this column as zeros. Okay, so now we just run a loop. Okay, so for this particular row that we have marked 0 over here, so for every column we need to make it 0. Okay, so we just replace 3 0 and for 9 as well. So this entire row becomes 0, and the next step is for the column. So we have a 0 here which we have marked for the column. So we just run a loop for every row within that column. So we just mark them at 0. And once we set all the values within this row as zeros, we need to also do the same for the columns as well. So we replace only the 6 with this 0. Okay, so this is the third step. So now we have completed the third step, and the final step is based on these flags. Okay, so we have the first row has true value to be true, right? So we just run a loop just for the first row and replace every single number with a 0. Okay, so if it actually needed, so even though if this is a 0, so it doesn't matter. So we replace all the numbers with zeros. Okay, so since the column is false, so we do not do the iteration here. Okay, so we do not mark all the first column values as 0, okay, since this is false. So I hope you understood these 4 steps in solving this particular problem, set 0 matrix, and what is the time complexity involved in this. So of course this is a time complexity of O of n square, okay. So this is an inevitable process because we cannot skip the comparisons between different elements. So we are forced to solve this in a time complexity of O of n square. So that is, we are doing it 2 times, right? So we set O of n square plus n square, which should still constitute to O of n square, okay. So at least it is not 3 times just as we saw in the brute force, okay. So we have just simplified this, and the best part is we are not creating any kind of additional data structure, although we are creating one for the 2 values, but this is irrespective of the matrix size, okay. So we just say the space complexity is just O of 1, okay. So this is the solution for the problem set 0 matrix. Let's see how can we code this. So first I'm going to calculate the number of rows and columns that we have within our matrix. So I'm just going to store this within rows, and I'm just going to calculate the length of the matrix, which stands for the rows that we have over here. So I can just say matrix dot length. All right, and for the columns I can just grab the first element and calculate number of elements within that array, okay. So I can just do a matrix at 0, or it can be anything, and then we just want to calculate the length of that, and we can just call this calls. So once we have done that, let us now execute the first step, which is to check if we have any zeros within our first column or first row, okay. So we can just store that within a constant or a variable here. Like we can call this first row has 0. Okay, so this is going to be a boolean value. By default it is going to be false. Later if we find a value which has 0, we are going to make this true, and let's do the same for the column as well. So let's replace this with call. First call has 0. So now let's start by running a for loop for every row that we have and check if there is a 0 or not. So we can just do a for let j equals 0, j less than calls, and then incrementing j. So inside this loop, we just want to check if the matrix at this particular iteration is actually having a 0 or not. So we can just do matrix at the jth value, and then want to check that if it is equal to 0. My bad, this should be at the first row, okay. And now we just want to set this to true, okay. First row has 0 and make that to true. So with that done, we can now do the same for the columns as well. So I'm just going to duplicate this logic and then change the variable name from j to I. Okay, so I'm just keeping I for rows and j for columns. Okay, so j is less than, sorry, I is less than rows this time. So at the ith iteration at 0th index, and then we want to update the column value to be true. So this matrix 0 means the first row, basically this particular row, and then iterating over it. So from here, here, and here. And then for the column means for the first row, so basically this particular row, and then we are just gonna go in the column wise. So from here, here, and here. Okay, so that's what this particular logic says. So we have completed the first step. Let's now move to the second step, where we need to set markers if we find any 0 apart from the first column and first row, where we need to start from the first index from the row and the column. So if we find this as 0, then we mark this and this particular values as 0, and then later populate them with zeros. So let's start with the rows first. So we can just put a for loop, and by putting I this time as the first index, okay, so basically representing this element over here, I less than rows, and then incrementing I. Okay, so inside this again we just want to put another for loop. Yes, this is a nested for loop because we want to mark the row and the column as 0, right? So that is why. So let's put a let j equals 1, j is less than calls, and then incrementing j. So inside this we just want to put an if check over here. So basically at the particular matrix where I and j are present, so if this particular element is 0, then we want to mark these two values as 0. So we just want to say matrix at I and at j. If that equals to 0, then we just want to mark the matrix. So basically this element over here and this element over here as 0. So we can just do that by matrix at I at the 0th index to be 0, and the same for the column as well. So matrix at 0 at j, and that should be 0. Okay, so I hope you understood this particular part. So these two elements are now 0. Okay, so the next step, which is the third step, is to populate wherever we find the 0, wherever we marked those two as 0, we just want to replace all the values as zeros within that particular row or column. So let's put another for loop right below this. So we can just duplicate the same logic down here, and inside this block, basically we are back over here within this element. Now we just want to check if these are actually marked as zeros, then we just want to populate them by zeros. So let's put a if over here, and basically this same thing, and we can just put a or operator and check any one of these are actually 0, then we just want to make that particular element as 0. Okay, so we can just say matrix at I and at j. So at the current iteration within this nested for loop, make that as 0. Okay, so we have executed the third step. Now only the fourth step is remaining, where we need to check if the first row has 0 or column has 0. If any one of these values are true, then we want to make that entire row or column as zeros. Okay, so we just want to check first if this particular value is a truthy one, then we just want to populate them everything by zeros. Okay, so we can just use a for loop, and inside here we can just start from the 0th index. So then from that particular iteration, we just want to mark that value as 0. So we just set matrix, and this has to be strictly 0 and not any other value, because we just want to check the first row, right? Go across that particular row and mark every element as 0. Okay, so let's now replicate the same logic for the column as well. Okay, so if first call has 0, then we just want to, let's make this I. So for every column, we just want to mark the respective value as 0. Okay, so that's the basic logic. Most of the things I have just duplicated. So we just have 4 steps. If you just understood these 4, then you would be able to solve this in an easy way. And this has to be rows and not calls. Sorry for that. And also here I have just used a single equal operator. So we just want to compare, right? So we just use triple equal to, and yeah, so that's were the mistakes. Now let's run this file and check if everything works and everything passes. Okay, so this is the solution for the set matrix zeros, and so this is the solution for the problem set matrix zeros. And so now let's move ahead to the next problem. So this is a problem called as product of array except self. All right, so the statement says, given an array nums, return an array answer such that for each value within the nums array is equal to the product of all the elements that we have within our nums array except the current element. Okay, the product of any prefix or suffix nums is guaranteed to fit in 32-bit integer. So now we just need to make sure that we write in an algorithm of and time complexity, all right, without using the division operation. Okay, so for example, we have this array 1 2 3 4. So for every value we have within the array, we need to make sure that it is equal to the product of all the other elements that we have within the array. So if we multiply 2 into 3 into 4, so the value is 24, right? So we just need to replace 1 by 24, or we need to create a new array and return that. Okay, so if I calculate the product of 1 3 and 4 except the self, so 2 is self, we don't want to multiply that, so that comes to 12, and the same goes for others as well. So let us understand in deep how exactly this actually needs to be solved. So these are the numbers that are given, where we need to find the product except the self. Okay, so what is the brute force way of solving this problem? So what we could do is, so we can just set a variable over here to store the product for the current iteration. So initially it's going to be 1, because 1 into anything is the same number. So now we just run a for loop, so where we set I and j over here. Okay, so I should have brought this product little more down. So now I and j, both the values are equal. So what the problem states, so the product of array except self, so we do not want to include the self value of this. Okay, so we just skip this iteration and move j to the next value. Okay, so now we find that j is not equal to I, so now we multiply with the product. So 1 into 2 is 2, so we set the product to 2, again increment j, again 3 into 2 is 6, and then increment j, so 6 into 4 is 24. So once we have completed the first iteration, then we just push that to the results array. So okay, so this is the first iteration. Now we increment I over here and set the value of j to I. Okay, so this is j. Okay, so and now we just multiply that with the product. So again the product gets reset to 1. So now 1 into 2 is 2. So, sorry, this time since I and j are equal, so we do not carry the product for this. So now we increment j over here, and then now we check the 3 into 1 is 3. So we update the product to 3, and then increment j and multiply the same with the value of j. So 4 into 3 is 12. All right. So now we increment I, then bring back j over here. So since I and j are equal, so we just don't do that. We increment j over here itself and reset the product over here. So the product is 1, and now what is that? That is, so now we calculate 4 into the product into 2 into 1, that is 8. Okay, so we update the product to 8, and then we once we complete the j iteration, we add that to the results array, and we just keep doing this. Okay, so finally once I and j are over here, so once they are equal, so we just don't consider 4. Okay, so we just add the rest of the elements, that is 3 into 2, that is 6. Okay, so we add 6 over here, again 6 into 1 is 6. Okay, so this is the solution. Okay, so this is brute force. What is the problem over here? We are just recalculating the same values again and again. Okay, so those were even previously calculated. As I told you in every video, when we do nested for loops, we are recalculating values. So what is the time complexity? That is of n square, and we are not creating any additional space, or we are just creating over here based on the number of inputs. So the space complexity becomes O of n. Okay, so this is not the best solution. Let us see a slightly more efficient and optimal solution for this particular problem. So what we could do over here is we need to construct a prefix array and a suffix array. Okay, so basically we need to loop across every element twice, okay, within this nums array. So note that we are not creating nested for loops, but we are iterating this twice. Okay, so the time complexity is just O of n plus n. Okay, which should still be O of n. So that is the time complexity which we are going to solve this problem with. So again, as I told, we need to create two arrays. One is for the prefix and one is for the suffix. I'll just tell you what is the exact trick which we are going to apply over here. So we will set a flag, or sorry, not flag, variable over here called prefix. Okay, and the value of that is just going to be 1, just as we did for the product. Okay, in the previous brute force way. So we set prefix over here, and then we just run a loop over here, this time with just one pointer I over here, and then we have a result array. Okay, so this is based on the number of inputs that we have within our nums array, number of values. So based on that, we just need to fill all the values with ones. Okay, so just so that when we multiply anything with this, so the value will be itself. Okay, 1 into something is itself, right? So now we start the loop. So when I is over here, so the first step is whatever the value we have within our prefix, we update within our result array. Okay, so this is our result array. So the prefix and the current element, so that is at the ith index. Okay, so I is pointing at the 0th index. Okay, so we need to also update that for the prefix value in this result array. So now prefix is also 1, the value of the 0th index is also 1, so it doesn't matter, so the values are still the same. So now we just increment I. Okay, so once we increment I, now we need to update the value of this result array for this particular prefix. Again, the prefix is 1 and the value is 1. So once we update this, we update the prefix, okay, to this particular nums value within this original array which was given as an input. Okay, so we just update this to 2. Okay, since the value of I is 2. Okay, so now we increment I. So currently I is at the second index. So now we just update the value within our result array with the prefix, that is 2. So this becomes 2 over here within our results array. Okay, and then we update the value of prefix. So the value of I over here is 3, right? We need to multiply the value of prefix with the current value of I. Okay, sorry, I just thought we need to replace. So that's not the case. We need to multiply this. So what is 3 into 2 is 6, right? So the value of 6. So now we increment I. Okay, now we just for the value of for the index I, that is at 3, within our results array, we need to replace that particular index, that is at index 3, with the value of prefix. So we just update the 1 with 6. Okay, so now we just multiply 6 into 4, that is 24. So 24 becomes our prefix. Anyways, it doesn't matter, we have ended our loop. Okay, so this is the prefix array. Okay, so this is one array, so that is prefix array, but still it's the result array, but we have just prefixed, okay, with one value. So now we just need to go in the reverse direction. So that is for suffix. So this is, we have calculated the prefix product Now we need to calculate the suffix product, and that will be the solution for the end. So that will be the end result, okay, which will be the actual solution. So we just need to loop across the original array itself, which is unmodified, from the reverse order. So currently I is over here. So now we loop this in a reverse order, and this time it is not prefix, it is called as suffix. So now we loop across the nums array in the reverse order. So the first step is to multiply the current index at I, and we just need to update that results array to the value of suffix. So we just need to multiply that. So 6 into 1 becomes 6, and we just need to update the value of suffix. Okay, so we just need to multiply the current index or the value of I, which is 4, into the current value of suffix. So that is 1 into 4, this becomes 4, and then we decrement I this time. Okay, so again we keep doing the same thing, multiply the suffix to the current index of where I is. So I is at the second index. So here we just multiply 4 into 2. So this becomes 8. So now we update the value of suffix to by multiplying it with the value of I. So that is 4 into 3 becomes 12. Okay, and then decrement I. So I hope you get the idea. So now we again we just multiply the value of the results array for the current index at I. So in I is at the first index, we multiply the value of suffix, that is 12, to 1. So this becomes 12. Update the value of suffix from 12 to 2. So this becomes 24, and then we decrement I. So I is at the 0th index now. So now we multiply suffix with the current index where I is at. So we update this to 24. Okay, and then we again update the value of to suffix by multiplying it in the current value of I. So that is 24 into 1 is still 24. And if you see that, we have obtained the result. Okay, so this is after suffix. So this is the second iteration where we actually find the solution. So the first loop is to store all the product of elements before I, and this time it is after I. Okay, so this is the second loop. So this is the particular idea how you can actually solve this particular problem, product of array except self. Okay, so what is the time complexity involved in this particular operation? So we are running two loops, right? So the time complexity would become O of n plus n, which should still constitute to O of n. Okay, so we have reduced the complexity from O of n square to O of n within this particular optimal solution. And what is the space complexity? Since we are creating the results array, right? So that would still be dependent on the number of inputs. So if it is 1, 2, 3, 4, the product array would still be of the same length. So we say the space complexity is O of n. Okay, so this is the solution for the problem, product of array except self. Let us see how can we solve this by code. So now let's get started by creating an array which is of containing every value as 1 based on the number of elements that we have from our nums array. Okay, so first let's calculate the number of elements that we have within our nums array. So we can just do that by nums.length. Okay, so now we can just create a results array and store all of the values within our length as ones. So we can just do that by saying result and using the array constructor by saying new array. So here we pass in the length, that is n, and then we have a method called as fill. Okay, so we want to fill every element by the number 1. All right, so this will just give us a results array of if we have 4 elements, then all the 4 elements will be 1. So now let's start by looping across every element for the prefix product. Let's now calculate the prefix product. So let's store the prefix initially to be as 1, just as any number multiplied with 1 is actually 1. So let's now put a for, and for so I equals 0, I is less than number of elements that we have from our nums array, and then incrementing I. Inside this for, we just want to update the results value by setting initially to the prefix value. So whatever the prefix we have currently, we just want to update the result at that particular iteration with that value. So let's put the result at I and make that equal to prefix. And now we just need to update the value of prefix. Okay, so now prefix becomes prefix into nums. Okay, nums at I. All right, or if this is this is actually repeating, we can just shorten this by saying star equals. Okay, just as we do for plus equals, right? We can also do the same for star equals. So we need to update the value of prefix by taking the previous value and then multiplying that by the current value of the particular iteration. All right, so once we have calculated the prefix, now we just need to apply a reverse for loop to calculate the suffix product, and that's the actual product we need to return at the end of the program. So let's put a suffix, sorry, 1. And now after this, we just want to put a reverse for loop. So we just want to set for I equals n minus 1, setting that to the last element within our array, and then I is greater than or equal to 0, and then decrementing I. So within this reverse for loop, now first we want to update the result value. So the result at the particular iteration of I, and multiply that with the current value of suffix. Okay, so we just want to, we can actually do that the same thing just as we did for the prefix over here, saying star equals and then the suffix. So basically updating the particular iteration of the result with the current value of suffix. So now once we have done that, we just need to update the value of suffix. Okay, so we just say suffix is equal to the previous value of suffix multiplied by the current value and the nums array. Okay, so this is the solution. I know this seems a little bit confusing to understand. I hope the explanation which I gave you how to calculate the prefix product and suffix product should do the understanding, right? So let's now finally return result. Okay, so this is the logic. Let's now run the code and check if everything works. And yeah, so everything passes. So this is the solution for the product, for the solution product of array except self. Now let's move ahead to the next problem. So this is a problem called as spiral matrix. Okay, so you'll be given a matrix which is represented as an array of arrays. So we just want to return all the elements in the matrix in a spiral order. So we just want to go in the clockwise direction where we start from 1 2 3 6 9 8 7 4 and 5. So we just want to loop across every single element, and this has to go in a spiral order. Okay, so this is the problem statement. Let's understand how can we solve this. So this is a matrix that is given, and we just need to return all the elements within the spiral order, okay, which is in the form of a clockwise. So we start from 1 2 3 4 and then go from 8 12 11 10 9 5 6 7. Okay, so we are going in the spiral order. So we just need to return all those elements in the form of an array. Okay, so this is the problem. So how can we solve this? So to solve this particular problem, we need to keep track of boundaries. Okay, so considering this particular matrix, we have 4 boundaries, right? So one is top, one is bottom, one is left, and one is right. Okay, so we just need to keep track of all of these values. So what is the value of top? So top is in the 0th element within this particular array, right? So we just store that within a particular variable and set that to 0. And also we see that left, the value of left is also 0 because that is the first element within the column. Okay, so for every row that we have, so the first element is the left value, right? So we store the value of left to be 0, and then we have another value that is right. Okay, so that is the last element within the row. Okay, so we have right, the length of the matrix, so that is 0 1 2 3. So the value of right is 3, and then the last thing is bottom, right? So bottom is basically the number of rows that we have. So we have 3 rows, so bottom is at the second index, right? So this is 0 1 and 2. Okay, so I hope you understood. So this is top, which is at 0, left is 0, so right is the index of the last column, and then bottom is the last row that we have within our main matrix. Okay, so in this main array, so this is the values. We have set boundaries, so now we just need to start applying loops. Okay, so we just need to apply 4 loops. Okay, so for every dimension that we go across. So for, let's start with the first value, so that is at number 1. So when we want to solve this problem, we need to make sure that we are currently inside boundaries. Okay, so always whenever we go across every loop, we just need to make sure that we are obeying the conditions. So what is the condition? The top value should always be less than or equal to the bottom value, and then with the value of left value should always be lesser than or equal to right value. Okay, so only then do we go across every single element. If not, if any one of these conditions fail, that means that we have reached at the end of our spiral. Okay, so we have gone across every single element, and then we have everything within our result array. So basically we'll be having a results array, and we just keep on pushing elements inside this. Okay, so now we start by applying the loop from left to right. So where the value of left is 0 and the value of right is 3. So based on these indexes, we keep on pushing to the results array. So we push 1, 2, 3 and 4 to the results array. Okay, so since we are traversing from left to right, okay, so once we do that, we need to update the value of top from 0 to 1. Okay, so now the top has shrinked one level below. Okay, so the top is over here now. Okay, so now we go to the next dimension, that is from the right. Okay, so now we loop from top to bottom. So the value of top is 1 and the bottom value is 2. Okay, so we start from the first index and then go to the bottom. So that is we add 8 and 12 to the results array. So once we have added the values for the second dimension, now we just decrement the value of right from 3 to 2. Okay, since we are now going from here to here, since we have already finished these values, so it becomes here. So now we have completed 2 dimensions out of 4, right? So we just need to, we have updated the value of top and we have updated the value of right. So we just need to check within this particular conditions it still obeys or not. So if it doesn't obey, so we skip that particular iteration. So now currently we have top, that is a value of 1. So top is still less than bottom. Okay, so this value is 2 and then left is still less than the value of right. So this is also true. So we just continue the iteration. Okay, so now we have stopped at 12. So we just need to now go from the reverse order since we are currently at the third dimension. Okay, so we just apply a reverse for loop from here. So currently the value of right is 2. So here, so we just add 11. Okay, and then 10 and then 9. So once we have completed the third dimension, then we upgrade the value of bottom. So we need to push the bottom over here, bottom line over here. Okay, so we decrement bottom from 2 to 1. And then finally for the fourth dimension, still the value of left is less than right. So we start from the left, that is at 0th index, and go all the way up to right. So right is at number 2, so second index. So we just add 5, 6 and 7. Okay, so now we just increment left. Okay, since we are left was over here, so now left becomes over here. So this is the solution for the problem spiral matrix. So basically what we are doing is we are shrinking boundaries for every traverse that we make. Okay, so for every traverse that we are shrinking it. So after the first iteration we are shrinking the top, and then from the second iteration, so basically from the right sides for the second dimension, then we shrink the dimension of right, and then from the bottom as well. So we just keep on shrinking boundaries. So this is the uh, actual strategy how you can solve this particular problem. Okay, so what is the time complexity involved? So that is O of m into n. Okay, so where m into n stands for the dimensions of this 2D array. Okay, so that would still constitute to O of n square. Okay, so this is the time complexity. And what is the space complexity? It is O of n. Okay, so basically we have all the numbers from our given matrix within our results array. Okay, so this is the solution for the problem spiral matrix. Let's see how can we code this. Okay, so let's start by putting a base case over here. Suppose for matrix length is 0, then we just don't want to unnecessarily run the loop. So we can just say matrix at dot length. If that is equal to 0, then we just want to return an empty array. Okay, so now we just want to first of all set the results array to be an empty array, and then we just want to add them one by one. Let's set result to an empty array. So now we just want to set boundaries, right? So that's the first step. So as we keep on traversing across our matrix, we just want to shrink the boundaries. So we all do that within the loop, which will come after this. So first let's define all the boundaries. So let's first set top to 0, and then we have the left to be 0. So okay, so these are the two which are going to start from the initial point from the array. Okay, so I'm going to send that to 0, and now we just want to calculate for the bottom and the right values. Okay, so to calculate the bottom, it is actually the length of the whole matrix, right? So basically it contains 3 rows, so we just want to get the last row. Okay, so we can just get that by matrix dot length minus 1, since arrays are 0 based. So bottom is equal to matrix dot length minus 1, and to calculate the right value we just want to get the last column, right? So we can just grab the first particular row and then count till the last element. Okay, so here we can set right, and we can just grab that by the first element and then calculate the length of that. -1. Okay, so once our boundaries are defined, we just want to run a loop. Okay, so this is going to be an infinite loop where we just want to keep on checking for values as long as they obey the boundaries. Okay, so we can just put in inside a while loop by setting a condition as long as our boundaries actually are defined or within range. Okay, so first thing we want to check is, as I told within the explanation, the top value should less than or be equal to the bottom value, and the second condition is the value of left should be less than or equal to right. Okay, so within this we just want to start running our loops. So we can start by moving from left to right initially. So I'm just going to say left to right. So inside this we can just put a for loop for every element we have within our row. Then we just want to keep adding that to the result array. So let's set I equals to the left value, and then I less than or equal to right, and incrementing I. So inside this loop we just want to push all the elements to the results array. So result, we just want to push all the elements. Okay, so basically top represents the row index, right? So we just want to push the matrix at top, the top value, and then the I value. Okay, so once we have done that, we can now increment top. Okay, so since we have completed the top elements and push them to the array, so now let's do the same for the right. Okay, so I can just copy this particular logic and then update all these things. So we can now say right to bottom. All right, so let's now traverse across our boundaries. So I is set to the value of right this time, and till the bottom. So now we are going column wise, right? So the first index within a matrix should be the current iteration, so that is I, and then we want to set right as the next one, since we are going from the last element. So right is set at the last by basically the column. So we just want to add all those to the results array, and then we want to shrink the right boundary to the left. So we just want to decrement right, since right is set to the last element, so we just want to decrement that. So now we have shrinked two boundaries, one is top and one is right. Now we just want to still check within this particular condition. If it still obeys, then we continue from the other dimensions as well. If not, we just want to break the loop. Okay, so now we just want to check if the value of top is still less than the value of bottom, then we just continue from the right to the left values. So now I'm just going to paste that this particular thing. Now say from right to left. Okay, so now we just want to update these values. So here we are moving from right to left, so we want to update these values from here, and just the value from bottom to left. Okay, and now we just want to push the matrix, since we are going from the row wise. So we just want to set the running index to this second particular element here. So replace this with I, and this has to be bottom, right? Since we are going from the bottom value, so we have set the value of bottom right here and checking the condition. So we just want to set bottom and then add the height value. Okay, and now we just want to decrement bottom. Okay, so once we have done that, let's now run our final loop from the bottom to the top. Okay, so again here we just need to check again for the next condition over here. As long as left is still less than right, then we just want to do the carry on the iteration. So we can just put here, if left is still less than right, then we just want to carry on the iteration. So I can just paste in here. So we are going from the bottom to the top. So let's update these variables as well. Okay, so since we are going from the column wise from down to top, we just update this particular value to the running index I, and then update this. So basically this is the left, right? So we just want to set left here. Okay, so we are going from here to here, this from down to bottom. So yeah, and now we update the value of left. So we just want to increment left. Since we are started from 0, we want to push from left to right, right? So we just do that, and yeah. So I hope you understood the four particular loops that we are running. So this will actually once we run a loop, it will update the boundary, and the same for the other dimensions as well. So now it will still check this condition. If top is still less than bottom and left is still less than right, then it will just carry ahead with the same thing again. Okay, so this is the solution. Let's finally run this. So we just want to return the result as well, right? All right, let's run. Sorry, I just made a small mistake here, and this has to be top to bottom and not from right to bottom. Right to bottom क्या होता है? So let's update this from top to bottom, and that's why we are getting the wrong answer here. And one more thing, this has to be greater than or equal to, and sorry for that. And also we of course need to decrement this. Okay, so since we are applying a reverse for loop. Alright, so now let's run this, and this time it should work. Okay, so this is a solution for the problem spiral matrix. All right, so yeah, I know this is a bit confusing to understand. Even I also struggle a bit to understand this particular logic, and I just tried my best to explain you this. Okay, and sorry if I haven't explained my best to for this particular problem. So this is the solution. Let's now move ahead to the next problem. So this is the problem called as jump game. All right, so here they're saying you are given an array of integers nums. So you are initially positioned at the array's first index, and each element in the array represents your maximum jump length at that position. Okay, return true if you can reach till the last index, otherwise false. All right, so here they're given a numbers array. So here we are initially positioned at the first index. So once we like here the value is 2, right? So we just need to jump 2 places, and we just need to check if we can reach till the last index. Once we are able to reach till the last, we need to return true. Okay, so I know this sounds a little bit confusing. Let us understand a bit deeper. So these are the numbers that are given 2, 3, 1, 1 and 4. We need to check for every number that we go across, will it reach till the last number. Okay, so the trick to solve this number is we need to find for every number like what is the maximum distance it can cover. So for example this 2, okay, so it can go up to the index 2. Okay, so it can go 1 2, so it can go till here, so that's the maximum distance it can cover. What about this 3? It can go up to this till this last number. So in order to solve this particular problem, we need to keep track of a variable called as, let's say, let's call this farthest. Okay, which means that which is the farthest number that a particular number can actually travel. Okay, so initially it will be at 0 because we are actually starting from the first number. So over here, so we need to keep on updating this number as we loop across all these numbers. Okay, so basically let's treat this as indices. So 0 1 2 3 and 4. Okay, so if I just go to this value over here, so at the 0th index the value is 2, right? We need to go to the second index. So what is the value over there? So the value is 1. So the farthest distance so far we have covered is 2. So we need to update this 0 to 2. Okay, so basically we just need to apply the math operator, which one is greater, 0 or 2, and based on that we update this particular variable. All right, so now let's go to the second index. So for the second iteration the value is 3, so we just need to go 3 steps ahead. So we go from 1 2 3 over here. Okay, so what is the value over here? That is 4, right? So we need to compare 2 and 4, which one is greater. So 4 is greater, right? So we update the variable to be 4. Okay, so for the current value of I, so what is the value of I? That is 1, right? So we need to check if this particular value 1, is it greater than 4? No, right? So if it is greater than 4, then we return false there itself, because whenever we jump to a particular number, so it gets stuck there itself. Suppose if I had a 0 here, and if I jump to this number, this particular 0, so I cannot jump any further because this value is 0, right? So it gets stuck here itself. So that is why we are checking if the current value of I, if it is greater than this farthest variable. Okay, so only then we return false. Okay, so if we reach till the end of the iteration, okay, which means that we have traveled across every single variable. Okay, so we have reached till the last, so we return true. Okay, so basically we just do this after the loop completes. So if we do not get stuck anywhere, then we return true. All right, so let's put this back to 1. Okay, so now let's go to the third iteration. So basically over here, so what is the farthest distance can this actually go? So it can go till the third index, right? So we just check if number 3 and 4, which one is greater. So 4 is greater, right? So we don't update this. All right, and now we check if I is greater than this farthest. Okay, so 3 is not greater than 4, so we continue the iteration. So we go to the next iteration over here, and over here we just need to jump one step over here since the value is 1. So what is the index over here? Index is 4, right? So we need to compare with the current value. So 4 and 4 both are equal, so we don't do the updation. So now we need to check if the current value of I, so that is 4, if it is greater than this farthest, so it should always be greater. Okay, only then we return false. So currently it is the same value, so we continue the iteration. So now we have come to the last iteration over here. So we just check after this whole process, we just return true at the end of our program. Okay, so that's the only trick. So let us consider another example where we are not able to make till the last number. So these are the numbers. So during the first iteration itself, if it makes a jump 1, 2, 3 over here, okay, so it gets stuck here. Okay, so it will not be able to move to 4 since the value is 0. So we cannot jump 0 times. Okay, so that is the place where we return false instead of true. All right. So when it comes to this particular trick, so we just name the indices over here 0, 1, 2, 3, and 4 over here. So during the first index, so it goes 1, 2, 3 over here, and we just update the value of farthest to be 3, and for the current value of I, which is 0, it is not greater than 3, so we don't return false. So now we go to the second index, so basically over here, so we just jump 2 numbers over here. Okay, so over here the what is the index, that is 3. So again we update this to 3, anyways both are same. So now 1 is lesser than 3, so we don't return false, we go to the next iteration. Okay, so over here we have the value of 1, so we just jump one step to the right. What is the index over here? That is 3, and over here is also 3, we don't update. So now 3 is equal to 3, so we just don't do anything over here. So we just go to the next iteration over here. So here we are stuck. Okay, so the value of this thing is 0. So anything like if I just go here also, it will still be 0, so it cannot make a next move. So there also we need to put a check, so if the value is 0 or not. So over here we don't make any jump, so we directly go to the last iteration. So over here you see the value of I is 4. Okay, but what is the value of farthest is 3, so 4 is greater than 3, so in that case we return false. All right, so this is the entire trick that we follow. So nothing much complicated, it's just few lines of code which if we understand we can solve this very easily. So what is the time complexity involved in this operation? So since we are iterating through this array just once, so the time complexity will just be O of n. Okay, so what is the space complexity? Are we creating any additional variables? So we are just creating one, but that is irrespective of the number of elements that we have. So we say that the space complexity is O of 1. Right, so this is the solution to this problem, jump game. Let's see how can we solve this by code. So let's go ahead and initialize the variable. So I'm just going to call this farthest. Okay, so initially it's going to be 0. So now we just want to loop across all the numbers and we just want to check for that condition. All right, so let's say I equals 0, I is less than nums dot length, I plus plus. All right, so inside this we just want to check that one condition, right? So that is if I is greater than farthest, which means that I is the maximum position that it can reach. So in that case we return false. All right, so if that's not the case, then we update the farthest variable with the current value. Okay, so we can just say farthest is equal to math dot max. So we just want to compare the maximum value of the current value of this farthest, and then we just want to check once for the I value. Okay, I plus the distance it has traveled, that is nums at I. Okay, so this. All right, so I guess this is the solution for this. So let me just, so once we have looped across every single element within our array, so we just want to finally return true. Okay, so let's try to run this. Okay, so all of our test cases are passing, so let's submit this, and okay, so that's looking good. So this is the solution for the problem, the jump game. Okay, so let's move on to the next problem. This is the problem called as longest consecutive sequence. All right, so you'll be given an array of unsorted integers called as nums. So we just need to return the length of the longest consecutive elements in sequence. So you must write this in an algorithm that runs in O of n time. Okay, so that's also a condition right here. So this is the given array. So what we just need to now do is we just need to check which is the longest consecutive sequence that it can form. Okay, so if I consider this to be an example, so the longest consecutive is 4, because when I start from here, 1 is there, so the next number is 2, so 2 is also there, 3, and then 4, so 5 is not there, right? So we just need to, so the longest consecutive sequence is 4, so we just need to return 4. Okay, so that is the problem statement. Let us now understand how can we solve this. So these are the numbers that are actually given. So in order to solve this particular problem, we just need to loop across every single element that we have and check if the next element is actually existing within this array. So we just need to keep track of a variable, like we can call this a streak. Okay, so we can call this current streak. Alright, and initially it will just be to 0. So we can just loop across all these elements. So for the first index, the value is 100. So we need to check if the next value, so that is 101, if it is existing within this particular array or not. So if it doesn't exist, so the streak will just be 0. So here the next value is 4. So 5 is not there, which is the next number within this array, which is not there. So we just don't update this particular variable. So again 200, there is no 201 in this. So when it comes to 1, there is 2. So the next number is 2, right? So it exists over here. So we just update the streak to be 1. Okay. And then from 2, we need to check the next value. So that is 3. So does 3 exist? So yes, it does exist 3. So we just again increment the streak to 2. And then we check if the next number of 3, that is 4, does it exist? So it exists over here. So we again increment the streak. Okay. So after 4, 5 doesn't exist, right? So we have completely broken the streak over here. We just keep on continuing and we just need to keep checking if the streak, if we find another streak that could break this particular record over here. Okay, so 3 is the record, so my bad, it should be 4 because the initial value should actually be 1. Okay, whenever we find one, because that's the one streak that it could find. Okay, so we just initialize this to 1 and currently it is 4. So we were at the here this index, so that is third index where the value is 1. So now we go to the next index, that is 3. Do we have any variable that is 4? So 3 plus 1 is 4, so 4 exists over here. Then we increase the streak. So previously it was 4, we need to reset it back to 1, so now it becomes 2. So now after 4, is there any 5? So there is no 5, so we don't do anything. So we just reset the streak back to 1 and then move to the next iteration, that is 2. So again 2, after 2, 3 exists, so we increment the streak. So this time streak becomes 2. Then after 3, 4 also exists, so we increment the streak to be 3. Okay, and then we need to check after 4, 5 doesn't exist, right? So the maximum streak was 3, but previously it was 4, right? So we also need to keep track of a max streak variable. So previously it was 4. Okay, so we need to compare the current streak if it is greater than the max streak. Okay, otherwise we just don't do anything. So if it is greater than max, then we update the value of this max to be this particular current streak value. Right, so this is the value which we need to return at the end of our program. Okay, so now let us see another example. So in this example, again we have the current streak. Okay, initially the value will be 1. Okay, so basically in this particular index, so what does the next value actually exist? So 2 exists, right? So increment the streak to 2. Okay, so after 2, 3 does it exist? So the maximum streak which we have actually recorded is 2. Okay, so we reset this back to 1 and go to the next iteration. So currently over here, currently it is actually starting from 0. So 0 plus 1 is 1. 1 exists, right? So we increment this to 2, and then again after 1, 2 also exists over here. So we increment this value to be 3 right now. Okay, so after 3, so sorry, after 2, there is no 3 that is existing within our array. So we just need to update the value of max. Okay, so currently the max value is 2, but the current value is 3. Okay, so we just update the max value to be 3 and then reset this back to 0. All right, so now we go to the next iteration, and again we have just seen this previously as well. Okay, so we just need to return this max value to be 3. Okay, so what is the time complexity involved with this particular operation? So say the time complexity is O of n, because we are just iterating once. And what is the space complexity? So you might be wondering, in order to find that particular next element within this array, so don't we need to run another loop? We don't necessarily need, because we can convert this whole thing to a set. Okay, so this can be a set. Okay, so the set data structure, in order to access a particular value, so the time complexity is just O of 1. Okay, so whatever the value we pass inside that has function will not loop across every single element, but it will just find that particular address and pick it up from there. So the time complexity over there is O of 1 and not O of n. Okay, so technically this should be like O of n plus 1, so which would still constitute to O of n. All right, so this is the time complexity and this is the space complexity, that is O of n, because we are creating a set, right? So all the elements that we have currently, so that will be in our set. So we are having 4 values, so that will be the space complexity, that is O of n. Okay, and also these 2 additional variables, so that would still be O of n plus 2, and that is of course just O of n. Okay, so this is the solution for this problem. Let us see how can we solve this by code. So let's get started by converting this nums array to a set. Okay, so I'm just going to call this num set. The reason why we are converting this to a set is to get rid of all the duplicates, which actually is not needed. So and also in order to access an element in a set, it takes a time complexity of O of n instead of O of 1 instead of O of n. Okay, so let's convert this to a set and pass in nums. Okay, so once this is converted, we just now need to loop across every element from the set and check if it has a next value. Okay, so the current number is 1, so we need to check if 2 is present in the original array, right? So we can just loop across the nums. So I'm just going to use a for of loop. So select num of nums. So now we just want to check if the number set dot has, since this is a set, we can access the has method, so we can just check for the previous value. Okay, so if that doesn't exist, then we just want to calculate the streak. If not, we just want to skip this iteration. Okay, so let's create the variable. So we can just call this current num, and we can just set this initially to the num. Okay, so now we just want to set the streak just as I told. So initially is going to be 1, so let's call this current streak and set it to 1. Alright, so now we just want to run a while loop just to check like as long as the next particular value is actually existing or not. Okay, so we can just say while and numset dot has, so we can just check for the next number if it exists. Okay, only then we increase the streak, okay, from 1 to 2, and then update the value of current number. So here we say current number plus 1. All right, so if the next number exists, so we just want to increment the current num and the streak as well. Okay, so let's increment this and as well as the streak. Okay, so once that's done, we can now update the value of the max streak. Okay, so we can just create a global variable here called as max streak, and this is what we want to return at the end. Okay, so let's say max streak, and initially is going to be 0. Okay, so now we just want to compare that to the original value of the streak, that is current streak, and then update this value. So let's update max streak and set that to math.max and then the max streak. Okay, and then the current streak. So whichever the value is greater, that will get updated within this variable. Okay, so current streak. Okay, so finally we just want to return the max streak. All right, so this is the solution. So what we are doing is we are converting the nums array to a set, okay, and initializing a max streak. So for every number we have within our nums array, basically this condition is when we do not want to include negative numbers. Suppose the number is 0, so 0 minus 1 is minus 1. So we do not want to count for that. Okay, so now we just want to set the current num to be the actual num, and then the streak is 1. So if the next number exists, so then we increment streak. So as long as the next number exists, we keep on incrementing the streak. Okay, and then finally we check the max streak. Okay, so if that is greater than the original value, then we update that. Okay, and once all of our numbers are iterated, we finally return the value of max streak. Okay, so let's run this and just check what is the status. Okay, so I made a typo here, max. Okay, so all of our cases are passing. Okay, so let's see our performance. Okay, so this is the solution for the problem, longest consecutive sequence. Now let's move on to the next problem. So this is a problem called as search a 2D matrix. Okay, so you'll be given a 2D matrix like this. So they have given each row is sorted in non-descending order. Okay, and the first integer of each row is greater than the last integer of the previous row. So basically what they're saying is, if this is the next row, so 10 is always greater than the previous row, that is 1, right? So the first element, first integer of each row, 10 is always greater than the previous one. It doesn't matter. So this is like a sorted matrix. So it's from 1, 3, 5, 7, 10, 11, 16, 20, 23, 30, 34, and 60. So it is sorted. Okay, so only thing is this is in the form of a matrix. So they have just given it in the form of a matrix like this, which is a 2D matrix. So here we just need to write in a solution with time complexity of m into n. Okay, so basically we just need to take advantage of this sorted matrix where all the elements are sorted, and we just need to solve this in the least time complexity. So that is O of log of m into n. Okay, so here we are also given a target. Okay, so that is 3. So we just need to check if 3 exists within our matrix or not. Okay, so if it exists, then we return true, else we return false. Okay, and we just need to solve this in O of log m into n time complexity. So let us understand how can we solve this. This is the 2D matrix that is actually given, which is in the form of an array of arrays. So we just need to solve this in the time complexity of log of m plus n, m into n, sorry. So to solve this, we can flatten this array, or we can assume to be this as a single array. Okay, so basically in order to access any element, so we just say like matrix at I at j. So based on this we can access any element. Okay, so basically using this particular approach we can just find that element. But so here we just need to apply binary search as though this is a single one dimensional array. Okay, so in binary search what we do, so we take the first element and the last element, and of course that array should be sorted, and we grab the mid element, we check if the target value is greater than or lesser than that, then we can just keep on eliminating values, and based on that we just search the particular value. If that value is actually the mid value, then we just return that itself. All right, so it's just like I also gave you an example of a telephone directory where instead of, if you are searching for the letter, let's say H. Okay, so we don't have to start from A, B, C, D. So we can just search for the mid element, that is like M or N, and check if the value of H is lesser than or greater than N. So it is lesser than, then we eliminate all those values after N. So we just have a small subset of that. Okay, so similarly this also works. So we have like from 1 to 60 which are actually sorted. So we just need to find the mid element. So the mid element is like 11 or 16. So based on that we eliminate these values. So we check for the target value, if it is greater than or lesser than, based on that we just keep eliminating values. Okay, so that's the binary search which we need to apply over here. So we just need to keep track of few variables. So first is the left value. So the left is basically the start of the 2D array. So we can just initialize this to 0, and right can be the last element. Okay, so how to calculate the last element? So as I told you, this is it is calculated by the rows multiplied by the columns. So basically we have 4 columns and 3 rows. Okay, so if we multiply both of them, so that would become 12. Okay, so 12, and also we need to subtract 1 since arrays are 0 based. So 12 minus 1, so right value is 11. Now we calculate the mid element. So what is the mid element? So if I take the average of left and right, so 11 plus 0 divided by 2, 5.5, and we just need to take the floor value of that, so that would just be 5. So we need to find the value which is at the index 5. So that is 0, 1, 2, 3, 4, 5. Okay, so this is the value, that is 11. Okay, and here we need to check the target value, if it is greater than 11 or lesser than 11. Based on that we update the values of left and right. Okay, so let's say the given value is 5. Okay, so that is lesser than the mid value, right? So we just update the value of right to be the value of mid, right? So the what's the value of mid, that is 5. So we update right to be 5, and then we calculate the mid element. So the mid element is 5. So we have actually found the mid element, so we just return that particular number. Okay, so if you see the time complexity over here, we are not actually calculating for the rest of the items. So we only see that if the number is greater than or lesser than. So we need to take advantage of the sorted array. Okay, so you see that after 11 we are not even checking for these values. We are, and over here within this array also we grab the mid element and check which is greater or lesser. We eliminate the half of that as well, and we just need to keep on doing until we search that particular element. Okay, so that's how we binary search actually works. So that's the advantage. So what is the time complexity? That is of log n. Okay, or log of m star n, so m into n, so that would still, like, let's say log of n. Okay, and what is the space complexity? We are not creating any variable, so we can just say O of 1. Okay, so this is the solution to this problem, search a 2D matrix. So let's see how can we code this. So now let's go ahead and set those 4 boundaries. So that is from all these corners, okay, basically. So now let's go ahead and set our boundaries. So I'm just going to start off with the left and the right, okay. So basically we want to start from 1 and go all the way up to 60, okay. So we just want to set left to 0, okay, and the right value is going to be the last element of this matrix. So we can just set right, and we can just calculate that by multiplying the rows and columns, okay, from the matrix. So I'm just going to store this in a variable called rows. So let's calculate the rows, that is the nothing but the length of the matrix, right? So basically there are 3 rows over here, which is the length of this matrix. So we say matrix dot length, all right, and then the columns we just set, we can just take any one of the row and calculate the length, okay. So we can just say calls and set that equal to matrix at the any row, okay, dot length, okay. So now we can now calculate the right value by saying rows multiplied by columns, and then we just want to subtract 1 since arrays are 0 based, okay. So now we just want to run a while loop while setting the 2 pointers. So one is left and till the right, okay. So we say while left is less than or equal to right, okay. So we just want to just keep on checking for the values and update the value of left and right, okay, based on like if it is greater than or lesser than the target value, okay. So let's first calculate the mid element. So we can just say let mid, and we can just use the math.floor to get the exact value, okay. And we just want to calculate the average of left plus right and then divide that whole by 2, okay. So once we calculate the mid, okay, so we now need to calculate the value of what is at the mid, right? So we can just say let mid val, and we want to extract that from our matrix. So we just say matrix. So since it's a 2D matrix, it will take in 2 square brackets to get the exact value. So here for the first thing is we just want to calculate the floor value. So since again we are just dividing two numbers, okay, so there can be decimal as well. So we just take the floor value of that, okay. So it doesn't matter, you can take floor value or you can take the seal value also. So we can just say maths.floor, and then we calculate mid. So basically this divided by calls, okay, to get the mid value. And then for the second one, we just want to take the remainder of the value while we divide mid with calls, okay. So we just say mid percentage calls, okay. So this will give us the mid value. So we can now check if the mid value is greater than or lesser than the target, okay. Let's say we found the value, let's say if that is equal to target, then we return true, okay. So we just say mid val, if that is equal to target, then we just want to return true. So if that's not the case, then we want to check if it is greater than or lesser than. So else if mid value is greater than target, or we can say lesser than target, then we just want to update the value of left. So left is going to be the value of mid, okay, and we just want to increment 1 since arrays are 0 based. And if that's not the case, so if mid value is greater than target, so we just want to update the value of right, and again, so that is going to be mid minus 1, okay. And finally we return false if we do not find the target. All right, so let's run this, and all of our cases are passed. So let's submit. All right, so that's looking good. So this is the solution for the problem, that is what is that, search a 2D matrix. So let's now move ahead to the next problem. So this is a problem called as insert interval, okay. So basically we'll be given an array of non-overlapping intervals, okay. So basically this intervals, okay, so basically it's an array of arrays where one is the start interval and one is the end interval, and also will be given a new interval, okay. So out here this is our new interval, which is the start and end of another interval, okay. So this is another interval. So we just need to insert this new interval into this intervals array such that this intervals is still sorted in ascending order by start at I. So basically I stands for this iteration over here, so that is 1 6, and then also the end also. Okay, so that is 3 and 9, and they still do not overlap. What do we mean by overlap is, so after 1 3 then comes 6 9. Okay, so there is no overlap in between them, so we need to insert this new interval to this intervals array, and then we need to return that. Okay, and they have said that we don't have to modify this intervals array in place, so you can make a new array and return it. Okay, so you see that 1 3 6 9. So if we merge this interval 2 and 5, so that becomes 1 5 and 6 9. You see that there is still no overlap. The intervals 2 and 5 are in between 1 5 and then 6 9. All right. So I know this sounds a little bit confusing to understand. Let us understand a bit deeper. So let us consider this example that is given here, where we have like about 5 intervals, and you see that intervals are like from 1 to 2, 3 to 5, 6 to 7, and there is no overlap in between them. All right. So this is the new interval that we need to merge within this existing array of intervals. All right. So the intervals which they have given us 4 comma 8, so we just need to merge them such that they do not overlap. Okay, and it should maintain the same consistency just as how it is over here. All right. So this interval 4 8 comes between 3 and 10. If you see these numbers, so 3 is like 4 comes after 3 and 8 comes like before 10 over here. So we just need to like merge this into 3 comma 10, because already 4 and 8 comes in between this. Okay, and also we see that it is consistent 1 2 3 10 12 16, and there is no overlap as well. So the problem is, how can we solve this? How can we actually apply a logic in our code? All right, so we need to have a new intervals array which we will be returning in the end. So let us create this array. So whenever we do not find any overlap, so we keep pushing the intervals to this array. Okay, so which we will be returning in the end. So currently we need to loop across all these intervals that we have within this intervals array, and we need to compare with this new interval for each array. Okay, so let us start with the first one. So here the numbers 1 and 2 and the new intervals 4 and 8, do they actually overlap? So 1 and 2 is separate, 4 and 8 is different, so they don't overlap, right? So we just add 1 comma 2 to this this new array. All right, so now we go to the next step over here. So 3 comma 5, so you see here 4 is overlapping right in between 3 and 5. So over here we just need to create a new interval and then push inside this new array. So in this case what we need to do is we need to compare the start and end intervals. Whichever is great, we need to consider that to be our new interval. So let us create another variable here called as new interval. All right, so now we just need to compare 3 and 4. Which one is smaller? We just need to put that as a start interval for the new one. So 3 is smaller, right, when we compare 3 and 4. So end interval 5 and 8, which one is greater? That is 8, right? So we just need to add 8 over here. So the start interval should always be smaller and the end interval should always be greater. So we create a new interval out of that. Okay, and then consider this over here as our new interval. All right, so now we just need to go to the next iteration. Okay, so I hope you understood what exactly we need to do. So instead of creating, we can just update this existing new interval itself. Okay, so we don't have to create a new variable. So before it was 3 8, so we just need to update this to 3, and this is 8 already. Okay, so this is our updated interval or this new interval. So now once we have updated this, we need to go to the next iteration. Okay, so over here you see that 6 and 7 overlaps again with our new interval, that is 3 and 8. So 6 7 comes between 3 and 8, right? So there is an overlap. Again we just do the comparison, 3 and 6, which one is smaller? Okay, so 3 is smaller, so we just don't do anything to that, and then we compare 8 and 7, which one is greater? 8 is greater, so again we don't make the updation. All right, so we now go to the next iteration over here. So between 8 and 10 and 3 and 8, is there an overlap? Yes, there is an overlap, because 8 and 8, so this is start and this is end, so even they should overlap. All right, so now we compare the start and end. Okay, so between 8 and 3, which is the smallest? So 3 is the smallest, so we just leave 3 as is. And 8 and 10, which one is greater? So 10 is greater, right, than 8, so we just update the new interval, that is the end interval, to 10. All right, so now we go to the last and final iteration. So over here we see that there is no overlap. between 3 10 and 12 16. Okay, so there is continuity. So 3 10, then comes 12, then comes 16, right? So there is no overlap over here. So we just end our iteration. Then we push this new interval to this existing array, that is 3 and 10, and then this last one which is not overlapping to this existing one itself, that is 12 and 16. Okay, so this is our final merged or inserted interval which we need to return at the end of our program. So the solution is 1 comma 2, then 3 comma 10, then 12 comma 16. Okay, let us now calculate the time and space complexity. So the time complexity, as you would have guessed, that is O of n, since we are looping across every item within the array. And the space complexity, the worst case is that we might have all the intervals within our array. So that is also dependent on the length of our array. So that always we need to calculate the space and time complexity based on the length of the array. Okay, so this is also O of n. All right, so let us see how can we code this. So let us start by initializing our results array. So we can just say a result, and we can just initialize this to an empty array, and then we have the iterator. So that is we can just initialize that to 0. So we can just say I equals 0, and then we have our length of our intervals array. So we can just also create a variable for that. So let's call this intervals dot length. So let us start with the first step. And just as I told, whenever there is no overlap, so we just add that to the results array, right? So let us execute that step. So we can just run a loop over here. So while I is less than the length of our intervals array, so basically we are looping across every single interval that we have, and also we just need to check if the end interval is greater than the start interval of this new, which is actually given. So I know it sounds confusing. So basically this 3 over here, which is the ending of the current iteration, if that is greater than or lesser than the start of this new one. So by this only we can check if it is overlapping or not, right? So we can just say intervals at our current iteration at the end one. So that is at the array 1. If that is lesser than our new interval at the start. Okay, so in that time we just want to push that particular interval to our result. Okay, so results dot push this current interval. Okay, so that is intervals at I. Okay, so once that is done, we just want to increment I. Okay, so if you want, you could have also done this with a for loop. Okay, and put a condition there, but this also works. Okay, so now we just need to go to the second step when there is an overlap, right? So we just want to merge the overlapped interval with our new interval, right? So here also we can just put a while loop. Okay, so while I is of course less than n, so in this case we need to check the start interval of our current iteration to the end interval of this new interval. Okay, so basically is the opposite which we are doing. So basically we want to calculate for the worst case. So that is if there is any overlapping. So we are just comparing this one with this 5. Okay, so this is the current iteration. So let's copy this, which is actually similar. Okay, so intervals at the start interval of our current iteration to the end one, so the end interval of this new interval. So we just say this one, and this should be lesser than or equal to, since we also want to check if these two are equal as well, so they also overlap, right? So inside this loop we just want to do the comparison, just as I explained, right? So we can just update the new interval. So that is the new interval at the first index, which is the start interval. So that is at 0. So this is the start interval. So in the here we just want to calculate which one is the minimum one. So we just do that by math dot min. Okay, so this thing, and then the current iterations end interval. Okay, and that is at 0th index. So that is the start one. Okay, so we just want to do the same for the end interval of this. Okay, for the new interval. So we can just duplicate this over here. So, and we can just update the end interval of this new interval to this opposite thing. So this time it is max, just as I told. For the end interval we need to calculate the max, and then this should be at the end interval. So that is 1, and this should be at the end, like so. Okay, so whenever there is an overlap, we update this new interval. Okay, so now we just want to push this updated interval to the results array, right? So we just first we need to increment I. and then we just do res dot push this new interval. So now there is just one thing which we need to do, that is after this new interval. So after we have updated this new interval, so whichever the elements that are there after that, okay, so we just want to add that to the results array, right? So we also want to include them, right? So we can just loop across the remaining items from the current iteration that we have left. So from this I, okay, so while I is less than n, so we just want to push the remaining intervals to the results array. So we just say res dot push, okay, intervals at I. Okay, so now we just increment I. Okay, again you can feel free to use a for loop if you find while loop a bit confusing. So finally we just return the response, sorry, the result. Okay, so my bad, this should be result. Okay, so over here as well. So let us now run this and check if everything is working. All right. Okay, so here there's a error here. So new interval at 0, and uh, this should be intervals. Okay, so my bad. So let's run this again, and this time it passes. All right, so let's submit, and yeah, okay, so this is the solution for this problem. Insert interval. So now let's move ahead to the next problem. So this is a problem called as next permutation. So basically we'll be given an array of numbers like 1 2 3. So we just need to calculate what is the next permutation. You know what is the permutation, right? So basically what all combinations that can actually be formed from these numbers that are there within this array. Okay, so basically the all the permutations of 1 2 3 are 1 2 3 1 3 2 2 1 3 2 3 1 3 1 2 and 3 2 1. Okay, so these are all the numbers that could be formed from these three numbers. All right, so whenever they give a number like this, so we just need to calculate the next value 1 2 3 1 3 2. Okay, so this is the next one. Okay, so we just need to calculate that. So the same goes for others as well. So let us understand how can we solve this. So in order to calculate the next permutation, we need to understand what exactly is the next permutation which they have actually asked. Okay, so in the question they have given an array of length 3, right? So there are actually 3 elements in the array. So what are the possible permutations that can be formed within this 3? Okay, so let me just consider 1 2 and 3. Okay, so what is the next permutation of this? If we read this as a number 123, what is the next possible combination, possible permutation that it can form is 1 3 2, just by using these 3 numbers. All right, so you see that after 123 132, and then we have 2 1 and then 3, then 2 3 1, and then we have 3 1, sorry, 3 1 2, and then 3 2 1. All right, so basically there are 6 permutations. So if we see all these numbers, when you read it like a number, it is in increasing order, right? So that is what is the next permutation. Suppose if they give you this 1 comma 3 comma 2, okay, so they tell you to calculate the next permutation, so that is 2 comma 1 comma 3. All right, so that is what we need to calculate. So in order to calculate the next permutation, we need to follow 3 steps, right? One is to find the pivot, okay, and then second one is to find the successor, and third one is to reverse the suffix. So let's go through it one by one. So first thing is to find the pivot. So basically whenever let's consider an example here, so that is 1 comma 2 comma 3, need to loop across this in the reverse order. So that is from the last thing. So we just need to check which is the number which is greater than the previous number. So that is if we go from 3 over here, so there is no next number. So if we go to the 2, 3 is greater than 2, right? So 2 becomes our pivot. Okay, so we say pivot is 2. So according to our logic, we need to find the first index that is greater than the previous one. So that is when we are looping from the reverse order. Okay, so if you see that this is the our first index which is greater than 3. So if this is like, let's say 1 now here. Okay, so since 2 is not greater than 1, so this is not our pivot. So we just need to go on to the next one, and when we go to the next iteration, you see that 2 is greater than 1. Okay, so 2 is greater than 1, so 1 becomes our pivot. Okay, so this is our first index. So whichever is occurring first, so that becomes our pivot. So let's bring this back to 3. Okay, so 2 is our pivot in this case. So our first step is done. So we need to go to the second step, which is to find the successor. Okay, so from right to left, we need to find the first element which is greater than our current number. So currently we are at this pivot 2. Let's consider this to be I. Okay, so this is our iterator I. So we need to loop again from right to left. We need to find which is the first number that is greater than this value which is at I. So currently I is at 2, right? So we can just put another iterator here called as J. So the value of J is 3. So 3 is greater than 2, right? So this becomes our successor. So I can just say successor. So basically pivot is the number which we want to increase. Okay, so basically 1 2 3, more than 3 we cannot, so there is no 4 5 or anything, right? So 3 is the last number, so we cannot increment 3. So we need to go to the second one. So we need to go one level previous. Okay, so over here 3 is greater than 2, so we just need to swap this. So this becomes our pivot which is I, and this becomes our successor that is J. So over here we need to swap these two elements. So with our pivot, so we just need to swap 3 and 2. Okay, so let me just replace this. Okay, so we have now obtained our next permutation. Okay, so you see that 1 2 3, after 1 2 3 is 1 3 2. Okay, so there is another step, that is to reverse the suffix, which in this case is not necessary. Okay, so let us now calculate for 1 3 2, which is the next permutation for that. Okay, so now we need to calculate the pivot. So let me just reset this. Okay, so now if we, what is the first step which I told you, finding the pivot, which we need to check from right to left, which is the first index greater than the previous one. So if we see 2, there is nothing after that. So 3, 2 is not greater than 3. So now we go to the next one. So now I is over here. So now you see that 3 is greater than 1. Pivot becomes 1. So basically 1 is the number which we need to change. Okay, because you see that there is, this cannot form 3 and 3, right? So we just need to use these 3 numbers, and within these numbers itself we just need to update to find the next permutation. So this is the number which we need to change. All right, so now we just need to find the successor. So we, as I told, what is the successor? As we loop from right to left, which is the first element which is greater than this value of I. Okay, so if I loop from J, so J is 2, right? So 2 is greater than 1, so our successor becomes 2. And then what I told, we need to swap these two numbers. So 2 and 1, and then the third step is to reverse the suffix. So basically this is the I index and this is the J index, right? So according to definition we need to reverse everything to the right of index I. So what is the right of index I? This 3 and 1. So we just need to reverse them. So whatever the numbers come after this, like 2 3 4, we just need to reverse all this. Okay, so we currently we just have 3 numbers, so we just reverse 1 and 3. Okay, so now we have found our third permutation. Okay, so that is 2 1 and 3. So previously we didn't have to do that. So previously what it was is like 1 2 3. So previously it was 1 2 and 3, so we didn't have to swap them. So it was like 1 3 and 2. Okay, so after we have swapped them, and then we just don't have to reverse the suffix because I is over here, and then J is the only element, that is the only element, right, which is after I. So we just don't do the swap over there. Okay, so that is why I skipped that third step, which was not necessary. So in the second step where we had 2 elements after I, so that is where we had to reverse that all the elements. Okay, so not swapping, reversing. Okay, so this is how you find the next permutation. Okay, so in case you found this a bit confusing, I'll just attach the summary over here on the screen, so you can just refer that. Okay, so what is the time complexity involved in this operation? So we are basically, they'll just give an array like this, so we just need to loop across this. So we are doing it 2 times, so that becomes O of n plus O of n, so which should still constitute to O of n. Okay, so this is not a nested for loop, so that is why it is just O of n. Okay, and space complexity is just O of 1. So because we are not creating any additional variables that is dependent on the size of this array. Okay, so let us now understand how can we solve this. So let us start by initializing our variables. So let's first calculate the numbers that we have within our nums array. So we say nums.length. Okay, so now we can just start with the iterator. So we can initialize this to 2 elements previously to this n. Okay, so we can just say I minus 2. The reason why we are doing is, one, that is arrays are 0 base, so we need to start with the end. So since this is the length of this array, so the length is 3, right? So if we consider 1 2 3, so 3 is the length, so we just want to start from 2. Okay, so if the length is 3, so we just want to start from the first index over here. Okay, so basically the last second index, so we just want to subtract that by 2. Okay, if we start from 3, there is no number after 3. Once that's done, we can now apply our loop over here. So we can first define our boundaries, so when I is greater than 0, and then we just also want to check if the nums at the current iteration is greater than the next number. Okay, so if that is greater than nums at I plus 1, so in that case we just want to calculate the pivot. Okay, so that number becomes the pivot, so we just decrement I. So if our current number, let's consider this one to be our current number, if that is greater than the next number, so that is not our pivot, right? So we just want to keep decrementing I. Okay, so as long as this condition fails, this I should keep on getting decreased. Once this condition failed, so that current value of I is our pivot. Okay, so this is our first step, so we can just say this to be our pivot. Okay, so this is the first step. Let's now go to the next step, that is to calculate the successor. All right, so let's call this successor. So let us put this inside an if block. So if by saying I is greater than or equal to 0, because this can go beyond 0 as well. So inside this, now we just want to initialize a variable called j, and again set that to the last second index. So we can just say let j equals n minus 1. Okay, so we can just set that to the last index over here, like so, and over here we just want to loop across the nums array. So now we just say j, while j is greater than or equal to 0. Okay, so by defining our boundaries, and now we just want to do the same while comparing the current value of I, which is our pivot. Okay, so this is our pivot. We just want to now check if that is lesser than or greater than that pivot. Okay, so we just say nums at j, if that is lesser than or equal to nums at I. Okay, so that is our successor. Okay, so if this condition fails, that is the successor, which is the value of j. Okay, so if that is not, then we just want to decrement j. Okay, so once this loop breaks, so we just want to swap the values of I and j. Okay, so let's swap them. So we can just swap by this technique like this. So nums at I and then nums at j. Okay, and we just do the same by using the square brackets, nums at j and then nums at I. Okay, so this is how elements get swapped. Okay, so we have executed our second step to find the successor. So now we just want to execute the third step, that is to reverse the suffix. Okay, so we say reverse. So this actually doesn't, if we just need to check the current value of I. So let's say I is over here. So the next values after I, so that is 2 and 3. So we just want to reverse them. Okay. So if I is over here, so we'll just have single element. So we didn't have to reverse, just as I explained in the example. So if we are having more elements after that, so we just reverse. Okay. So in order to do the reversal, let's set left to be the next value of I, so that is I plus 1. Okay, and also let's do the same for right, so which is the n minus 1, so which is the last element within this array. So that is 3 over here, for example. So if this is our array, so if I is at 1, so we just set left here and right to the last element of this. Okay, so once we have done that, we can just do the swapping. Okay, so this is just like how you do the swapping in palindrome, so to check if the string is a palindrome or not. Okay, so that's similar to what we are doing right now. So we can just put a while loop and check if, as long as left is less than right, so we just do the swap. Okay, so we just say num set left, so we can just copy this and replace with left and right. Okay, so num set left, num set right, num set right, and replacing that with left. Okay, so now we just want to increment left and decrement right. All right, so finally we return nums. So let's now run this and check if we are able to calculate the next permutation. Let I is equal to I minus 2, so this should actually be n minus 2, so my bad. Alright, so that looks good. So all of our test cases are passing, so let's submit. Wrong answer. I don't know why did this happen. Let's submit again. So I just missed a greater than or equal to here, so that is why it was failing. So let's check. Okay, so that is looking good. So this is the solution for this particular problem and next permutation. So that is it guys for this video. So I hope you like this 2-hour video on all the problems that are related to LeetCode arrays, okay, and that are of medium level. If you have come till here, congratulations in completing this 10 most important ones, and I hope you will crack one of those questions that will appear in your interviews as well. So if you have come till here, thank you so much for listening to me, and I hope this series has actually helped you. It took me a lot of effort to create this 2-hour long video, so I appreciate if you give this video a like and share it with your friends as well, so that they can get the best out of this video. And also let me know in the comments how did you come across this series, if you have liked it or not. Okay, so just let me know so that I can improve my teaching style as well. And yeah, so that is it for my side for this video. Thank you so much. So all the best for your DSA journey. All right, so thank you so much. I'll see you guys in the next video.